Welcome back at Jakajima TV. Today we're going to talk about food printing, 3D food printing with meat, and with a new technology developed in California. And Dan Rubinsky is talking about it. It's his invention with his team, and he's going to talk about particularly cryolithographic 3D printing of meat. So Dan, welcome at Jakajima TV, and would love to share to see what your project is, because it's a different approach.
Thank you very much. Yeah, this technology was actually developed at the University of California in Berkeley, in the lab of Professor Boris Rubinsky's biomechanical engineering lab, and it's originally developed for the development of organs for organ transplants.
Okay.
Yeah, that's quite a few years away. So let me kind of walk through what we are doing right now.
We know that because we're also organizing conferences on bioprinting and those sort of things. But okay, but this is food. Great.
Yeah, but yeah, we realized that food is a much quicker way to market for us. So we are a 3D printing company focused on cryolithographic parallel additive manufacturing. And today I kind of want to talk about our approach versus the traditional additive manufacturing. And what you'll see with our approach, it's really increase in speed, the reduction of costs, and the increase in texture, especially with alternative meats, which is a really big deal right now. So traditional additive manufacturing works on the X, Y, and Z movement, which means that everything's working within one platform. There's the X-axis, which goes back and forth, the Y axis that goes north to south, and then the Z platform, which goes up and down. Now, when it comes to the mass production of food, which we're really focused on, this is a slow process, because really what happens is you're printing one layer of food, and then you have to wait for that to be done. Then you print another layer of food on top of that, and then another layer of food on top of that. So if every layer takes 1 minute to print, if you want 10 layers high, then it takes 10 minutes to print that. Additionally, with food like alternative meats, it's not a binding substance. It's not chocolate. It's not dough, which are all these things that are being printed with 3D food printers right now. It's not binding. It doesn't attach to itself. So at the University of California, Berkeley, it was developed, this cryolithographic parallel additive manufacturing. And the idea behind this was really to increase the speed of the manufacturing process so we could actually industrialize this and go into mass production. And to do this, we broke apart the printing process. There is the X movement, the Y movement, and the Z movement. So my beautiful images here are more examples. This is the extruder. The yellow box is the extruder, and a nozzle, a tube goes into the nozzle, and that's really the X-axis, and that just goes back and forth. Now, the Y movement is actually the conveyor belt, which goes underneath it. So you can really print back and forth as this Y movement. So you're doing both movements at the same time. Now you can do a layer of meat, a layer of steak, pause, another layer of steak, pause, another layer of steak, and pause, and so forth and so on. So it's really a continuous movement of printing. Finally, at the end, you'll see that one layer gets flipped over, and then there's a robotic arm. And that robotic arm starts stacking those layers of meat, one on top of the other. So as it comes off the conveyor belt, the robotic arm takes it and boom, stacks it, then stacks it and stacks it. So as opposed to waiting, for the printer to print one layer and then go up the next, we're just continuously printing. Now, the key to this is that we don't only have to print on one conveyor belt at the same time. We can actually print on multiple conveyor belts at the same time. So then let's say, as my example, if it takes 1 minute to print one layer, a traditional 3D printer would take 5 minutes to print 5 layers. Print one layer, then the next, then the next, then the next. Well, for us, we can just print 5 layers on 5 different conveyor belts at the same time, which would take 1 minute. And then with the robotic arm, we would just stack them. So compared to traditional additive manufacturing, where we take 5 minutes for that one steak, it would take us 1 minute and change to print that steak.
Okay. Okay.
Additionally, you'll see here on the traditional manufacturing how there's no texture to what's being printed. But because the truth is you don't want to make contact with the layer below yours, or else you're going to mess up the CAD. With us, since we're only printing 1 layer, we can actually do something called intentionally making contact with the meat, the previous line that you printed, so we can have this very nice macro texture on what we printed. Now, where the cryo comes in is, as I said, meat is not a self-binding item. But with a secret combination that we have a food-safe material, that we create a binding mechanism, and freezing 1 layer to the next, we can create little almost spikes with the ice that we create that then bind each layer one to the next. And we end up stacking on either a frozen platform or within a vat of freeze-inducing liquid, like liquid nitrogen or a very cold kind of alcohol. Once again, food-safe alcohol that, not vodka, but like a different freezing material to make it as big as we want.
Okay. Okay.
So yeah, so then this is kind of an example of something we printed. I just want to point out the image in the middle is butchered meat. You can see that by the fat. Mm-hmm. But on the left and right side, that's alternative meat. We took a Beyond Burger, we slurried it like anything you need to 3D print. We slurried it, we printed it. You'll see the texture in the meat, which is really what causes texture when you bite down on meat. If you just try to print out a layer of meat with no texture, there'd be no bite, no bounce to it. But if you create the peaks and valleys within the meat, you get this great first bite of meat. So on the left side, you'll see the printed meat that we printed, and on the right side we took that meat and we cooked it, and you'll see it looks exactly like a butchered piece of meat from a cow.
Now, if you look at the process, and let's say the 3D printing process, let's say the traditional 3D printing process, is very often used also for creating nice designs and those sort of things. It seems, but I'm not sure, that with this technology, it's less, it's not as easy to make, let's say, very nice designs, but I don't think that is the target for this process. Is that correct, or am I?
No, that's exactly correct. The target for this project is not to make fancy cake toppings or chocolate, which is it's a great use of the technology. Our technology is really focused on the mass production of alternative meats. Okay. At this point, 100%, almost 100% of what alternative meat manufacturers print is ground beef. Yeah. But if you look at traditional meat manufacturers, only 39% of what they produce is ground beef. The rest is some form of steak. Yeah. Additionally, something else that we're also working on is the production of food for patients with dysphagia, which is a eating disorder that affects 1 in 25 people around the world, because we can create this great texture, and with a little slight change, if you bite it a couple of times, it actually breaks apart and allows you to swallow. Okay. So really what we're trying to do is get food out to the masses as opposed to fancy pieces of
Oh,
meat.
okay, so and how far are you now with your project? And you have a prototype?
Yeah. So we have a prototype in the lab that right now does the entire process. It has high volume printing. It has a continuous printing mechanism. It has the robotic arm that stacks. Right now we are in the process of looking for funding to industrialize this. With industrialization, we can get up to about 10 tons of meat per year, which on a cost level is actually very similar to the manufacturing of regular meat.
Okay. Okay, well, thank you very much, Dan, for this presentation about the new technology. Very interesting. I'm just curious how it tastes and how it sees. So I should come to you, I guess.
Actually, the taste is it's because for everything you print, you have to slurry it.
Yeah.
You can make it taste like anything. You can add teriyaki sauce. You can add spices. You can add really the taste is up to your imagination.
Okay. 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 Anyway, thank you very much. And as always, at the end of a presentation, interview, I ask a personal question. So a bit about behind the person who presented. So what is your favorite music or sport or city? So please go ahead, share it with us.
Well, I was thinking about this, and I've always loved the accordion. It's always been a dream of mine to play the accordion. I think it's one of the most beautiful. I've never seen someone who played the accordion who was not happy. So I've always wanted to play it. So with COVID, with this lockdown, I've had the opportunity to spend in a couple extra hours in the house, and I've been practicing accordion and teaching myself online.
Okay, so well, it's the first time I hear accordion as a sort of passion or as a new thing. So, well, thank you very much for your presentation, and look forward to see the continuation and the progress of your project and your alternative 3D printing technology. So, thank you very much.
Thank you very much.